Hi, hello everyone. As you might have gone through my previous video on concept of temperature, today we are going to discuss something about concept of heat. Without any further delays, we will go directly to the definition of heat. Heat is basically a form of energy, and like how energy has so many different forms: electrical energy, you have chemical energy, then you may have nuclear energy. Okay, so heat is also basically a form of energy. Now if it's energy, so we can utilize um, um, the units of energy to heat. So heat is basically a form of energy, and the unit of heat is joule as for every energy. Energy का SI unit is joule, so we will be using joule as the SI unit for heat as well. The CGS unit, erg is the CGS unit of energy. However, joule is the SI unit of energy. Calorie is one more unit which we are going to use while we discuss concept of heat. Following is the conversion factor between the SI system and the CGS system. So 1 joule is equal to 10 raised to 7 ergs, and 1 calorie is equal to 4.184 joules. So in the coming lectures of heat, we might be using sometimes as calorie, and you might need to convert that into joule. So 1 calorie is 4.184 joules. The dimensions of heat is basically of dimensions of energy. So L2m1 T minus 2 would be the dimensions for heat, and the instrument that measures heat is called as calorimeter. So yes, there are some practicals, and when we'll discuss concepts of calorimetry, and when you are going to discuss with discussion of Newton's law of cooling, we'll be using this concept of calorimeter. So this is an instrument which measures calorimeter. If you remember, temperature, in order to measure the temperature we need thermometer. In order to measure heat we will be using calorimeter. Okay, now this heat can flow from one body to another body. Heat can flow, but there are two conditions. Heat can flow either from a higher temperature region to a lower temperature region, or heat can flow from a lower temperature region to a higher temperature region. But there is a difference here. The difference is that heat can flow from higher to lower temperature, but that will happen freely. Like you need not have to do any work, or you need not have to do you do not have to work for this thing. But when you are making the heat flow from lower temperature region to a higher temperature region, you will have to do work. Like for the sake of example, we can discuss this same example which we discussed in one of the previous videos for temperature. Let's say we have a hot cup of tea, and the temperature of the tea is 80 degrees Celsius, and the surrounding is 20 degrees Celsius. So the heat is going to flow from the tea to the surrounding, which was flowing from higher temperature region to a lower temperature region. And same you can apply this example to a ice cold bottle. Let's say the ice cold bottle ka temperature is 0 degrees Celsius, and the surrounding temperature is 20 degrees Celsius. So the heat is going to flow from the surrounding to the bottle, and the bottle is going to become warmer, ice is going to melt, and the temperature of the ice is going to the temperature of the water will also increase. Now you have not done anything in order to make heat flow from higher to lower temperature. You just kept a hot cup of tea, or you just kept a ice cold bottle, and the heat started to flow. But when we are making the heat flow from lower temperature region to a higher temperature region, we'll have to do some work. Now the best example is present in our homes, and that is an air conditioner or a fridge. Now this air conditioner or a fridge has something called as a compressor, and this compressor does work in order to make our rooms and the fridge cooler. So the inside of a inside of a fridge or inside of a room, if you're talking about AC, we'll talk about a room. And if we are talking about fridge, we are talking about inside of a fridge. So heat from the inside of the fridge is thrown outside the fridge, and this is done by the outdoor unit, or you can say the compressor. For an AC, if this is our room, then heat is flown from the inside of the room to outside of the room. This is done by the outdoor unit of the AC, and which consists of a compressor. We'll be studying more about AC and refrigerator when we'll be discussing about thermodynamics. So make sure that you know that heat can flow from both sides, higher temperature to lower and lower to higher, but only difference is it will flow from high to low freely, but lower to higher you will have to do some work. Now, how does the heat flow? There are some modes of transfer of heat energy, and those modes are, as you are seeing on the screen, there are 3 modes of transfer of heat. So I've just made that in a tabular form, so you can see the mode, which modes we have, and the reason in each mode, and the medium in which it happens. So if you see, there are 3 modes of transfer of heat. One is conduction, the other is convection, and the third is called as the radiation. So there are 3 modes, 1, 2 and 3: conduction, convection and radiation. Now in conduction, the reason for transfer of heat is vibration of atoms. So the atoms and molecules vibrate at their own mean position, and the heat is transferred from one atom to another atom, and so on and so forth. However, in convection, it's the migration of the atoms, like moving of an atom from one point to another. In radiation, it's the electromagnetic waves which makes the heat energy transfer. Now, in solids, if you see, most of the atoms and molecules are at rest, so they do not move, so they can only vibrate. So if you increase the temperature, the atoms and molecules vibrate, and this vibration transfers the heat from one point to another point. This mode of transfer is called as the conduction. In solids, the transfer of heat is because of conduction. In liquids and gases also conduction can happen, but the major part is in solids. Solids may generally we see conduction. In liquids and gases also we can have conduction. In convection, what happens is it's the migration of atoms, that is, atoms and molecules move from one point to another point. So this can only happen in liquids and gases, because as we all know that in liquids and gases the molecules are not at rest, they are just continuously in a random motion. In solids, it's not like that. In solids, the atoms and molecules are having a fixed place, and they just vibrate at their own mean position. So in convection happens only in liquids and gases and never in solids. On the contrary, radiation does not need any medium. If there is a solid, if there is a liquid or a gas, if there is no medium, it's a vacuum, still radiation can take place. In order to explain this, all 3, conduction, convection and radiation, we'll see a small example. I have made 3 diagrams over here, and if you can see, there is a spoon here. Here there is a spoon, and this spoon is getting heated up from a small burner. Now as the atoms and molecules at this point of the metallic spoon starts vibrating more and more, just make sure that in our previous video we have discussed regarding temperature, and we said that even at 0 degrees Celsius the atoms and molecules still vibrates. It's not that atomic vibration goes off at 0 degrees Celsius. So we can always say that we are heating something at 0 degrees Celsius. We are heating at minus 20 degrees Celsius, and we are not wrong here. The difference is atomic vibration can go to 0 only at 0 Kelvin, and because atomic vibration can never go to 0 Kelvin is not attainable. Same it goes for the other way around as well, because 0 Kelvin you won't be able to attain, atomic vibrations can never go to 0. So at even the room temperature, the atoms and molecules of the spoon are in continuously random motion. They are continuously vibrating. They are continuously vibrating at some point. So this is the atom which is vibrating everywhere. But as you keep on heating, this atom and molecule will gain energy and it will start to vibrate more, which in turn will make the other atoms also vibrate. And as heating brings vibration, vibrations will bring heat as well. At some point in your life, you might have got a light uh, a small feeling of hotness at the other end of the spoon if you have heated one end of the other end of the spoon. So this is a mode in which the vibrations of the atoms and molecules makes the heat transfer from one point to another point. Such mode is called as conduction. Now let's see for convection. Let's say if we have a container like this and we have some liquid into it, and we are again heating that water or liquid with some small burner, then the molecules at the bottom, which I am highlighting by a laser, these molecules are going to get heated up, and as they become lighter, they will start to move in the upward direction. As these molecules start to move in the upward direction, they will give off their extra heat energy to other molecules present in the vicinity. So this way, even if you are heating the liquid at the bottom of the container, the entire liquid gets heated up. That's the reason you will see at boiling the bubbles come from the bottom to the top and not the other way around. Now here, when atoms and molecules, the bubbles, they move from one point to another point, when they migrate from one point to another point, heat is getting transferred to other molecules. Such kind of mode of transfer of energy or the heat is called as convection. Then comes radiation. Now we all might be having a microwave oven in our homes, and in a microwave we use microwaves from our electromagnetic waves. So electromagnetic waves are of many types. We have gamma, we have X-rays, we have UV, we have visible light, infrared, microwave, and radio waves. So out of which we use microwaves in a oven. And the property of electromagnetic wave is that whenever an electromagnetic wave is incident on a material, it heats up. So this property of electromagnetic wave is utilized in a microwave oven. So heat is transferred, and this kind of mode of transfer of heat energy is called as radiation. The much better example would be sun. So if you see, our sun is shining at a very large distance, and the energy of the sun is transferred to the earth at such a large distance, even though there is a vacuum in between. So this is just basically what heat is, how it is getting transferred, what are the conditions and the dimensions and the units of heat. More in following lectures, when we are going to calculate some transfer of heat, specific heats, and all those stuff. We'll be winding up this video. Subscribe the channel and hit the bell icon, and I would love to see some comments on the channel in order that to understand what my audience is needing, and is there any problem with the lectures or anything. If you like a lecture, just comment something better, and if you have reviews, if you have feedbacks, that's most welcome. Thank you so much.